Solving systems of equations by graphing. Let's start with terminology. A linear function is an equation which, when graphed, is a straight line. The slope-intercept form of a line is y equals mx plus b. A solution to a linear function is any ordered pair, x comma y, that satisfies the equation or that lies on the line. A system of linear equations is a group of two or more equations in the same two variables. A solution to a system of linear equations is an ordered pair x comma y, which is the point of intersection of two lines. So we'll start with a picture. This is a graph of a system of linear equations. We're asked to determine the solution to the system. So that is the point of intersection of the two lines. The solution to the system of equations is -4, 1. Now in this example, we're asked to graph a line, and this is just to help us review the slope-intercept form of the line. The slope of this line is the number multiplying the x. The slope is -2/3. The y-intercept then is 4. When we graph a line, we start with the y-intercept, and then we use the slope, down 2 and to the right 3, to graph our second point. We connect those points, and this is the line y equals -2/3 x plus 4. In this example, we're asked to solve a system of two linear equations, and we have both lines in slope-intercept form, so it would be a good idea to graph the two lines and see where they intersect. In the first line, the slope is 1/2, and the y-intercept is -2. So we'll start with our y-intercept, then we'll go up 1 and to the right 2, and we'll graph that line. In the second line, the slope is -1, and the y-intercept is 4. We'll start with our y-intercept, and then we'll graph that line. We can see that the two lines do intersect at the point 4, 0, which is the solution to the system of equations. We'll try another example, and we're asked to solve this system by graphing. In the first function, the slope is 1/3 and the y-intercept is -3. In the second function, the slope is also 1/3, the y-intercept is 1. Remember that the solution to the system of equations is the point at which the lines intersect. There is no solution to this system. So graphically, we know that there will be no solution if the lines are parallel, and algebraically, the lines will have the same slope and different y-intercepts. So that's an example of a solution of a system of equations with no solution. Here's our next special case. The first example is given in standard form. Now we could rewrite that in slope-intercept form, but we could also use the intercepts to graph the line. To find the x-intercept, we set y equal to 0. The x-intercept is 2. To find the y-intercept, we set x equal to 0. The y-intercept is 3. We can graph the x and the y-intercept and then connect them. And there is our line 3x plus 2y equals 6. Now the second line is given in slope-intercept form. The slope is -3/2, and the y-intercept is 3. So we'll start with our y-intercept, and then we'll go down 3 and to the right 2. And we notice that the purple line is the same thing as the pink line. They are the same line. So we say that there are infinitely many solutions. Graphically, the lines are the same, and algebraically, the equations are equivalent. All right, let's just summarize what we talked about in this video. Remember, if we have two lines that intersect in a point, This system of equations has one solution, and we name that solution by its x comma y format. So the solution of this system is -4, 1. Then we went over an example like this where the lines were parallel. They had the same slope but different y-intercepts. We say that there is no solution to that system of equations. And the last type that we looked at, remember where the two lines were one and the same, we said that this system has infinitely many solutions.